Hi guys, and welcome back to our second lecture. We will continue setting up our virtual environment, test it, and then discuss ways to make it resilient against virtualization detection techniques. But first, let's start by describing the techniques used to detect virtual environments and understand what exactly they are looking for. There are a number of reasons why a malware author might want to detect when his sample is running in a virtual environment. We have discussed the benefits of using virtual machines in the previous lecture. To recap briefly, we talked about the ability to run multiple software versions and operating system, isolation from production network, snapshot, automatic analysis, and collecting indicators of compromise, also known as IOCs. For these reasons, virtual machines are very frequently used by security researchers to analyze unknown samples, so obviously attackers want to avoid being detected. Most of the public and private sandboxes run on virtual machines. These are environments where one can submit samples to be run and analyzed automatically. A number of very good public online sandboxes exist and we encourage you to play with them. More details and links are provided on the next slides. Similarly, with the previous point, a lot of companies deploy honeypots that will present themselves as normal working servers with weak credentials and waiting to be compromised, which will then capture any attacker activity. Malware authors don't want their samples to end up in someone else's honeypot. Although very difficult to achieve, VM escapes are definitely possible and have been demonstrated before. There is incentive for attackers to escape from a virtualized environment, the host, where a lot of data and other virtual machines can be accessed. As we talked before, misconfigurations allow an attacker to pivot from a virtual machine and access production environments. This can happen when the network of the virtual machine is breached with the corporate network. When submitting samples to an online sandbox, be mindful that anything you share becomes public resource accessible to anyone. This includes the attacker who might become aware of the detections. Always verify that the sample you're about to upload does not contain confidential or sensitive information. Instead of submitting an actual file to be analyzed, consider submitting first only the hash of the file. This allows you to access the analysis details provided that the file has been analyzed before. Commercial variants of these sandboxes exist that are installed on site with private cloud support. There are multiple ways to detect virtual machines. Most of them fall into the following categories, as highlighted in a great paper by Tom Liston and Ed Scoudis from SANS. Looking for artifacts in processes, file system, and registry. For VMware, for example, there are hundreds of references to VMware tools or other related words inside registry and file system. Although there are many specific signs, most of these can be modified. Looking for artifacts in memory. There are two types of VM indicators in memory. Either actual text strings, similar with the above, or specific data structures related to a virtual machine present in memory. Looking for specific virtual hardware. For example, network, USB, and audio controllers in VMware have specific fingerprint. This can be mitigated by manually modifying this in the configuration of the VM virtual machine, but this process is largely undocumented. Looking for specific processor instructions and capabilities. Each virtualization software has specific processor instructions used for all purposes. For example, VMware establishes a communication channel with the host necessary for shared clipboard, drag and drop files, time synchronization, and so on by modifying certain x86 instructions. These modifications are documented and anyone can search for them. On top of these very specific VM detections, malware can use other, more general indicators not specific to a virtualization software to detect when they are being analyzed. Check the list of running processes for the presence of any analysis tools. Check the runtime and detect if too much time is spent between different points, basically indicating either a very slow machine or most probably a debugging session. Check if the application itself is being run under a debug. There are certain steps we can take to make sure our prepared virtual machine stays undetected. Change the VMware configuration options. As we mentioned before, there are some undocumented settings that can be modified in the configuration file, the one with .vmx extension, to make the virtual machine in a way stealthier, to look more like a physical machine. Remove unneeded extras, like share folders, drag and drop feature, shared clipboard. Although some malware families incorporate a lot of checks and won't run inside VMs, in many cases we might not even need to go to great lengths to avoid being detected. A lot of malware will happily run on virtual machines. Some examples include ransomware looking to encrypt data, worms hoping to propagate as much as possible, and others. To recap, in this lecture we've done the following. Studied the incentives for malware writers to detect virtualized environments. Discussed online sandboxes and how to use them safely. Looked at ways software can detect if it's running in a virtual machine or being analyzed. We've also seen how we can make our virtual machine more undetectable. In the next lecture, we'll look at a few pieces of code performing anti-virtual machine and anti-debugging techniques found in real-world malware and what we can do to bypass that and perform the analysis. Thank you and see you in the next lecture.